Hello, everybody. Hope we're doing well. So, I wanted to talk about a couple examples on the parent guide for the counting problems because I know that we didn't have too much full exposure to these types of questions. So, I just wanted to make sure that I address it now with you in hopes that this will prepare you for tomorrow's assessment. Now, I'm choosing not to go over the two-way tables because I think for the most part, looking at your homeworks, as long as you did it, I think a lot of people did a really good job in getting that done. And so if you still have questions tonight as you're working, just let me know. But hopefully the parent guides do help for review. For numbers 13 and 14, there is going to be a question where I'm going to ask you how many ways can you rearrange the letters from a certain word. So you have to think about all the current possibilities when we're working with this. And so we're looking at 13, right? And it's funny that the name is Karen. But if we're looking at all the possibilities, this one is pretty straightforward because they're all different letters. So when you're doing that, it's really just 5 factorial here. Because each letter has a possibility of being the first letter and being the second letter and third letter and fourth letter and fifth letter. So there's a lot of potential there. But 14 is a little different because they have a condition. How many ways can you rearrange the letters of the word Karen if you want the arrangement to begin with a vowel? How many vowels are there? There's A, there's E. There's 2 options. So for the first letter, you only have 2 choices to choose from. So you're going to multiply 2 times everything else is fair game. Everything else is fair game. So when you're multiplying it out, it's 2 times 4 factorial. And again, the reason why is because you have just those 2 letters as your first option. So if you were to make a decision chart, 1, 2, 3, 4, 5, you only have 2 choices in the first letter. But then afterwards, everything else is fair game. So as soon as you pick a letter for your first choice, you have 4 more left, and then 3 more left, and then 2 more left, and then 1 more left. So that's why they specifically have 2 times 4 factorial. Okay. And then finally, the last thing that I wanted to talk about with the words, I don't have an example on here, but I can use one of these other words just to help us out. So I'm going to actually use the word vanilla here in number 16. So let's see that our word that we're trying to rearrange is vanilla. Sorry for being a little small there. Vanilla. So if it was vanilla, we have to first count, okay, how many letters do we have to choose from? Well, there's total 7 letters in vanilla, so that's actually going to go on the top here. Now, the issue with vanilla is I can't just do 7 factorial straight. And the reason why is because there are repeat letters in the word. So in the word vanilla, there are 2 A's and there are 2 L's. So I need to divide this 7 factorial by the repeats of the word of each letter in the word. So I'm going to divide 7 factorial by 2 factorial to count for the A's. And I'm also going to divide another time by 2 factorial for the L's. So this is for the A's. And then this is for the L's. So that's how you simplify it if you have repeat letters. Okay? So all 3 of these situations are fair game tomorrow for one of the questions on the counting problem standard. So just be mindful. You have the total amount of letters up on top, and then you're taking away the potential amount of repeats that there are on the bottom. Okay? All right. 15 here. This is the last one we'll talk about. All standard license plates in Alaska start with 3 letters followed by 3 digits. If repetition is allowed, how many different license plates are there? Well, let's think. There's 26 letters in the alphabet. There are 10 different numbers that you can choose from for digits. So if I'm thinking about decision chart, there's a first decision, second decision, third decision for the letters, and a first decision, second decision, third decision for the numbers. So to start off, well, if we have letters, there's 26, right? So first choice, second choice, third choice, I have 26 letters. But repetition is allowed. So on the second choice, I have 26 letters. On the third choice, I have 26 letters. For the digits, there are 10 total digits. So I have 10 choices for the first one, 10 choices for the second one, and 10 choices for the third one. So all you need to do is just multiply all these numbers together. It's a very big number, but that's what it is. It's just 26 times 26 times 26 times 10 times 10 times 10. And the only reason why is because repetition is allowed. Now, if repetition is not allowed, this would end up being a permutation because order matters in how you put the letters and the numbers. So essentially, if you were doing a decision chart, it's a lot easier to do this kind of question with a decision chart. Here's what it would look like. Okay. So for a decision chart, on your first choice, you still have 26 letters. But if there's no repetition, well, you take out a letter. So it's 25. You take out another letter, 24. For the digits, if it's not repetitive, okay, well, there's 10 numbers to choose from for the first digit. There's 9 to choose from for the second, and there's 8 to choose from the third. So your number goes down because there is no repetition, which makes sense. If there's repetition, there are multiple options on getting those counting problems done. Okay. So hopefully that helps. The last thing that I wanted to briefly talk about, again, difference between permutations and combinations. So if we're looking at permutations, remember that permutations, I don't think I can make this bigger. Here we go. Permutations. No repetition. Order matters. Combinations. No repetition. But order doesn't matter. That's the difference between the two. So please be careful when you guys are reading your questions tomorrow. Please be careful in reading your questions. You got to make sure that you are understanding, does order matter? Does order not matter? Does it repeat? Does it not repeat? If it does repeat, the way that you rewrite, and if you guys remember how I did number 15 originally, the way you rewrite it is instead of doing, oh, this is very big. Instead of writing 26, 26, 26, 10, 10, 10, if order matters and there's repetition, you can just do 26 to the third power times 10 to the third power. Why? Because for letters, you have 26 choices, you have 3 decisions. For numbers, you have 10 choices, 3 decisions. So that was what that fundamental principle of counting was, where if there is repetition and order matters, like in a license plate, then you need to put choices raised to the power of decisions. So hopefully that helps. Again, if you have any questions before tomorrow, let me know. Hope you guys have a great day.